All right, this video is going to go over 2003 B, number 4, and this is a problem about coffee drinking and cholesterol. So I'm not going to read it to you, but just to hit some highlights. The problem is about studying the cholesterol level being affected by some new coffee filter. We have 300 non-smokers, and they all drink 4 cups of caffeinated coffee per day. We're going to have 2 groups, 2 treatments, an experimental group, this is the new filter, and a control group, this is the standard filter. And each participant's cholesterol level will be measured at the beginning and at the end of the study. So we're going to look at the change in their cholesterol level. Okay, so this is definitely a problem about experiment design. It involves very little or actually no calculations whatsoever. And so if you were doing this problem, the first thing to do would be to read all 4 parts before responding to any. So you can sort of see where the problem is going. And let's just go through part by part. Part A, we're supposed to describe an appropriate method for assigning subjects to the 2 groups. Okay, so we're not designing an experiment. We know it's a completely randomized design with 2 groups, and we need to describe a method. Okay, there are many ways to do this, and I'll provide an example of one, and we'll call this the HAT method, which is sort of a simple way to explain what's going on. So we assign each subject a unique integer from 1 to 300. We put 300 identically sized slips of paper in a hat. We draw out 150, one at a time with no replacements. The subject with the numbers corresponding to the numbers drawn will be assigned to the control group, and the remaining 150 will be assigned to the experimental group. This is a good response because it can be, if a person reads it, they can follow these directions and they will get the desired outcome. Important that this gives each group an equal amount of subjects. That's important. There are many other ways to accomplish this. You could say assign each subject a unique number from 001 to 300 and generate random integers from 1 to 300. And the first 150 unique integers selected, those subjects could go in one of the groups and so forth. But if you do that, you have to sort of address we're going to ignore repeats and stuff like that. There are many ways, but each way there are 2 things that has to happen. It has to be, if someone followed the directions that you give, that it would give the desired effect, and each group's got to end up with an equal number of subjects. Okay. So part B is talking about why a control group is important here. Well, without a control group, we would not be able to determine whether the observed change was due to some other extraneous variable. The control group eliminates confounding variables that might be responsible for the change in cholesterol level. For instance, suppose people's exercise habits change because the study was done in the summer. People might tend to be more active. So the change in cholesterol might not be due to the new coffee filter. With a control group, we can see if the change occurred in both groups or not, and if it didn't, we could attribute the change to the filter. So again, this is not the only way to respond to this question, but it's important here to do a couple things. Okay, and so I'm looking now at the rubric and what it takes to get an essentially correct on this problem. So here's what has to happen. We have to describe the need for a comparison group, and we have to explain what that allows us to do. And that is to attribute the change of the cholesterol to the new filter as opposed to natural or variability. You could also talk about confounding, sort of in the way I did, but you've got to describe the variable in such a way that it would lead to the change of the cholesterol levels during the 10-week period. Okay. Common errors here would be to just say that it allows us to compare. That's not enough. Another would be to say, well, it eliminates confounding variables, but not really being specific in how that can be, when we look at the change in cholesterol, how those confounding variables affect that. Okay, so There's a lot of leeway with the way you say this, but there's also some specific things that the rubric is looking for. Okay? All right. So moving on. All right, if we look at part C, and by the way, part A was scored essentially correct, partially correct, or incorrect. Same for part B, and then C and D are scored together. Part C is a real short answer. What test would you run to determine if the change in cholesterol is greater if people knew the new filter rather than the standard filter? Well, that would be a two-sample t-test. We're going to have the mean difference for those who use cholesterol after the study minus cholesterol before the study for those who use the new filter and for those who use the other filter. Okay, so it didn't ask you to set up, but this would be the mean difference of the filter is the mean difference, call it the new filter, the standard filter. That would be your alternative, your null hypothesis. It's a two-sample t-test. Okay, so that's all you really needed to say there. You had to recognize it's about means. You had to recognize it's not about proportions. You had to recognize it wasn't paired, that it's actually two-sample. Okay, part D says, why would the researchers choose to only use non-smokers in the study? So here's what I said. If it is known that smoking is related to changes in cholesterol level, it would be best to control for it by using only non-smokers. So my response is addressing that we're controlling for something, the fact that people smoke. And that eliminates smoking as a source of variability in our results, and that enables direct comparisons between the treatment and control groups and more precise estimates of the effects. But it does mean that we can't generalize the effects to smokers as well. So let's look at the rubric and see what exactly they were looking for. Okay, and so we can see here on the rubric that the response is correct if the student explains how smoking could be related to initial cholesterol levels at the start of the study, indicating that there is something different about the smokers. You could indicate a desire for more homogeneous groups, or say that we reduce the variability in the response. You can use the word confounding, but you really have to explain what that means in the context of this study. It's not correct to just describe smoking as a confounding variable. Okay, you really have to discuss why and how just including non-smokers would address that fact. Okay, and then here you can see how it's scored.